Today's problem is maximum sum of elements not part of LIS, longest increasing subsequence. Difficulty medium. Given an array of positive integers, your task is to find the maximum possible sum of all elements that are not part of the longest increasing subsequence. All right. A subsequence, the way I understand it, is different from a subarray. A subarray means contiguous elements. A subsequence is not necessarily contiguous elements. It means the elements are in the same order that they're in the original array, but they may not be contiguous. These examples don't really point that out. For example, the longest increasing subsequence in this array is this one right here, 1, 2, 3, 8, which is also a subarray. Same thing here. It doesn't really make that clear, but in any case, yeah. So here's the longest increasing subsequence. What is the maximum possible sum of elements that are not in there? It's the 4 plus 6, 10. Constraints: the array size will be between 1 and 10 to the third. 1,000. The elements, the numbers in the array will be between 1 and 10 to the fifth. 100,000. Expected complexity n log n. Company tags. FlipKart. I looked up FlipKart because it's turning up here a lot. FlipKart is it's an Indian e-commerce company. It's funny, if you go to their website for the first time. I went to the website, and all of the prices are in Indian currency, which is it's quite different. So it looks like you're paying, like $6,000 for a T-shirt or something, but it's a different currency. Topic tags, dynamic programming. Okay, I don't think it's really possible to get an n log n time complexity with dynamic programming. I think as you're building up the results, you're going to need a nested loop to look back at previous elements. So I don't think, I mean, you could do it. I guess the fact that they listed here, I mean, suggests that you could do it. You'd get an n squared algorithm, but I feel like it should work if they list it as a topic tag, but we're not going to do that. We are going to do something a little bit different here, and then we're going to use a tree map. Tree map is not I guess it's not a really commonly used data structure. For a map, usually we would use a hash map, but a tree map keeps the a tree map maintains the order of the keys, and by maintaining the order of the keys, it gives you some extra methods that are not available if you're using a hash map. We'll see those as we go through it. Let's see. Most of the work is done in this insert method, but let's take a quick look at the main method. What we're going to do is we're going to take every value in the array and insert it using this method into the tree map. Once we do that, really the work is done, but we will come back here and pick up the final answer. So first of all, let me scroll this up so it's visible. I'm trying to get as much white space as possible. We're not going to be able to do it and see this at the same time. So this is 4, 6, 1, 2, 3, 8. That's going to be our example array. Okay, let me grab a pen here. 4, 6, 1, 2, 3, 8. All right, 4, 6, 1, 2, 3, 8. All right, so that's our sample array. For variables, we're going to need len and sum. What is len is initialized to 1. Sum is initialized to val. Okay, so we're going to insert these in order. So the first time through here, len is 1 and sum is the first value, which is 4. Do we need anything else? Well, we need the map. We'll put the map over here. All right, so map entry previous equals map lower entry. Right now there isn't anything in the map. A tree map does allow you to use a method called lower entry. Pass in a value and it'll give you the next lower entry in the map. In other words, the entry whose key is lower than val. It's the closest entry to val, but lower. All right. Right now, there's nothing in the map. So if previous is not equal to null, previous actually is equal to null. There's nothing in the map. List. We have a list, a to erase list. I'm not sure how to sketch that yet. While next is not equal to null. Oh, I'm sorry. The first thing we come in here, First thing we come in here next is get the ceiling entry, the next higher entry than the val. But again, there's nothing in there yet. There's nothing in the map. While next is not equal to null. Next is equal to null. For in key to erase, there's nothing in to erase. So all we do first time through is put val in the array. Val is 4. And we put an integer array of length and sum, which is 1 and 4. Okay. Next entry we are going to enter is 6. Find a ceiling entry for 6. There is nothing in the map greater than 6. All right. Length is 1. Sum is val. So in that case, sum is going to be 6. Lower entry. Okay, so previous is going to be the 4. If previous is not equal to null, which it's not, then length is going to equal previous, which is the 4 entry, get value 0 plus 1. That's this 1 plus 1. So now we have a length of 2. Right? Sum is previous, get value. That's the 4 plus the value, which is 6. So sum is now going to equal 10. What's next? Integer to erase. While next is not equal to null. There is no next. There's no ceiling entry for the 6. So we can skip that. For int key to erase, nothing in that. Map put, so we'll put that in the map. The val is 6. Val is 6. And there's going to be length and sum. Okay. Good. Enter the next value. The next value is 1. Get the ceiling entry. Well, the ceiling entry for 1 is going to be 4. All right. So length is 1 and sum is value. All right. Let's take those out. Length 1, sum is value, which is also 1. We're now trying to find the best longest increasing sequence which ends at a value less than the current entry. So previous is lower entry. There is no lower entry for the 1. So previous is null. We are going to try to remove dominated entries. That's something where the length is less than or equal to the current length and the key is greater than the value. Maybe explain that as we go along, but list integer to array, new array, while next is 4. Next is 4. If next get value right here, 1, is greater than length, and it isn't. If it was, we would break. Otherwise, we're going to add the key to the to erase. I guess this will be to erase over here. We're going to erase the 4. Next, we'll go map higher entry than the 4, and that would be the 6. We'll go back up here. If next get value is greater than length, it is, then we'll break. So we'll break out of that. The reason we're going to take out the 4 is because the length is the same, but the sum here is greater. We're not looking for a high sum in the longest increasing subsequence. We're looking actually for a low sum in the longest increasing subsequence because we're trying to maximize the numbers that are not in the longest increasing subsequence. So what that means is we can remove the 4. All right. We are removing the 4. And we're adding, the 1 with the length and sum. All right, now a tree map would keep these in order. It doesn't really matter for us that we're not going to keep them in order, the map. What you gain from keeping them in order in the tree map is it gives you extra functions like ceiling entry, lower entry, next, higher entry, things like that. We can still use those, but we're going to now add this to the map. We have 1, we have 1, and 1. Right? What is the next thing to enter? Next thing to enter is the 2. Map, ceiling entry. The ceiling entry would be the 6. So that's next. Length is 1, sum is value. I can make that. Okay, so the length is 1, sum is 2. We're on the 2 now. Look for the best, longest increasing sequence at a value less than current. So let's see. Previous is map lower entry. So previous is this 1. If previous is not equal to null, which it's not, then the length equals previous get value at 0 plus 1. That is 1 plus 1. So now the length goes to 2. The sum is previous get value plus value. It's 1 plus 2. So that goes to 3. Okay? To erase, next array list, while next is not equal to null. Next is not equal to null. Next is equal to 6, the ceiling entry. If next get value at 0, which is 2, is that greater than length? No. So we're going to add to erase over here because we now have a better longest increasing subsequence. We have 2 and 3, which is better than 2 and 10. Again, we're not looking for high values in the longest increasing subsequence. So we add that. Next, map higher entry. There's no higher entry than 6. All right, so we'll just remove the 6. Okay, goodbye. And add the new entry. New entry is 2 with, or the key is 2, and the entry is length and sum. All right. We are now at 3. We're looking for a ceiling entry for 3. There is no ceiling entry for 3. Length is 1, sum is value. Actually, the value would be 3, so we can leave that, but this needs to be 1. All right, now we are looking for the best LIS ending at some value less than 3. Lower entry is 2. Is previous. If previous is not null, and it's not, then length equals previous get value at 0 plus 1. 2. So the previous get value at 0 is 2. And we're going to add 1. So the length of our longest increasing subsequence is now 3. The sum is previous get value 3 plus value, which is 3 plus 3. 3 plus 3 is 6. Okay. What's next? While next equals null. Next is null, so we're not doing anything here. We're just putting this into the map. There's the key, there's the length, there's the sum. Last number, 8. Is there a ceiling entry for 8? No. So length is 1, sum is 8. Length is 1, sum is 8. Previous is the lower entry. Lower entry for 8 is going to be 3. Previous is not null, so length equals previous get value 0. That's 3 plus 1. So length is now 4. Sum is previous get value 6 plus value 6 plus 8. 6 plus 8. Whoops. 6 plus 8 is 14. Let's see, let's to erase while next is not equal to null. Next is equal to null. So we don't do that. We don't do this. We just put this into the map. All right. So that's 8, 4, and 14. All right. Probably going to be good to remember that the last entry, because I can't scroll this and write at the same time. The last entry, the key is 8. The value is the array 4, 14. 8, 4, 14. All right. Let's try to remember that. Let's scroll it back up here. I'm going to write that down one more time. The last entry was 8, 4, 14. All right. So we have finished up to here. Now we say int last equals map last entry get value. All right. That's an 8. Get value is an 8. So actually, yeah, we could say last. Last is 8. Total sum is, convert the array to a stream and sum it. The array was 4, 6, 1, 2, 3, 8, which is 4 plus 6 is 10, 1, 2, 3, 6, 16, and 8, 24. Total sum, I'm going to abbreviate that as T. Total sum was 24. Okay. LIS sum equals last at index 1. So last is 8. This is the map entry, and at index 1 is 14. We're going to return the total sum minus the list sum. 24 minus 14 is 10. All right? That's the total sum minus the sum of the longest increasing subsequence. So it's 10. Let's double check that answer. And that is the answer. It's 10. It's the 4 and the 6. So anyway, that is how to do it with a tree map. Why is that n log n? Well, because we're processing every element in the array. That's n, and the access methods for a tree map are log n. Why are they log n instead of O of 1? Because the tree map has a little extra overhead to keep the keys in order. So it's log n. So it's n log n. And let me compile and run this just as a sanity check. Okay, that worked. And submit. All right. What did we learn there? Well, we learned a useful application for tree map. And please like the video, subscribe. You'll get problems of the day in your inbox, and we'll see you next time.